This is Robert Pagan, section NO3, Physics 2112. This is Lab 7 at-home video lab report, and basically the goal is to find the mass of a black hole using Newton's second law. The problem is use a program for finding Fnet and dPdt for a system in combination with the law of gravitational force, and with that, find the mass of the black hole at the center of the system. And our result was that the forces cause the changes in momentum. We're going to explain that later in what does it mean. And the mass of an object can be determined given all the components of Newton's second law. So we used the same program actually that we had in Lab 6 in class. The only things we added were right here. We created a new object, this hole, same radius as the planet or the star. We gave that a position. The star's mass remained the same as the in-class lab. Delta T was still 1 day, or 1 full year. So the star orbits the black hole 1 time in our program. We use the same formulas that we wrote before for finding delta V, delta P, dPdt, and Fnet. We're going to explain what those mean and how they're related in a second. And then the only other thing we added were we made the program print out different results, so it told us what Fnet, dPdt, so on and so forth all meant, just instead of us having to like calculate it or look for the numbers. And so we're gonna run this.
So I'm getting this right now. 1 second.
It always takes a little long. Okay, and so the blue arrow is the parallel component of Fnet. The red arrow is the perpendicular component of Fnet. And then the black arrow is just Fnet, and so those two like vectors, when you add them, they create the Fnet vector. That's why all this kind of works. If you want to look at linear algebra a little bit, so it's almost done orbiting 1 time here. Yeah, I'm just gonna close this because we already have the results. But the mass of the black hole is 1.9785 e to the 31. Fnet is the same as dPdt, 3.06. Fnet parallel is 1.35, same as dPdt parallel. Fnet perpendicular is the same as dPdt perpendicular. And so let's look at what that means. Fnet parallel, Fnet perpendicular, they're all the same as dPdt and the parallel and perpendicular components of that because they're all directly correlated. What is different about them is that Fnet is what causes dPdt and its components to be what they are. If you look at the formula, Fnet equals dPdt, like that's pretty clear. But Fnet is like the outside force. It's what's being added to the system. So then dPdt and its components are just results of that. What if, imagine the black hole's mass you found was replaced by a different black hole, same location, says assume the motion of the observed star is unchanged and affected only by the gravitational force. Could you tell the difference? Well, it's kind of a trick question because the path would be different if the mass was different, and then R would be different. Your Fnet would be completely different. And so, if the mass of the black hole is different, the star, for it to have the same path and for Fnet to be unaffected, it would have to, well, Fnet would still be affected actually because R would change, but for M1 times M2 to be the same, obviously they'd have to have the same product. So whatever the mass of the black hole was times some new mass for the star would have to equal what it initially did in our program and in the first experiment. And that's it. Thanks, y'all.